Hello.
Hello.
Okay. Okay, I think
Just,
we have most of the people joined, except
just Andrew is not here.
yeah.
How long did it?
Okay, it's okay. Yeah. So Miko, shall I start?
Yeah.
Okay. So we have Miko today. So I think I will leave the introduction to himself, but I will just have a small um, introduction on what we are, why we are here today. So last time we had a discussion with Miko, and he presented um, uh, um, a web application which was created using Cursor. So I think most of you are aware about vibe coding. So it was done on that approach. So we have requested Miko to present a session or give a session on vibe coding, so that our we have most of our developer here, and we have two product owner also joined in this call, in order to get some idea about how to do vibe coding in efficient way. Because we were quite impressed by the application that he have presented during last session that we had with him. That's why we have requested, and um, thankfully he have accepted to host the session. And yeah, I guess over to you, Miko.
Okay, thank you. So, yeah, maybe not all of you know me, so just a very brief personal introduction first. I am Mikko. I'm from Finland, and I have been working with software engineering for more than 30 years now. And past 25 years, I worked with AI. I was one of the early language model innovators, and then kind of past few years when these new generation LLM tools started to emerge, uh, I started to look for something, and what I started to look for is what I today call agent dev0, which basically is to say a drop-in replacement to an engineer, so that if I work myself on a project, it's more like I'm working with another engineer. And this is, of course, a pretty big shift in the world, because engineers are quite costly. Maybe in India, not so much, but in the Western world, engineers are very costly, and it's not easy to find good engineers. It's not easy to find reliable engineers, so forth. So it's actually a pretty big deal if we can kind of have this agent dev0, who is like a pair programming pair. So that's I've been kind of looking for that, and when the first versions of the LLMs came, since then I've been trying to kind of push that boundary, is to really see how far we can take that. And my test has always been to build an app. So can I build an app from zero to hero just by using the AI kind of partner, AI pair partner, AI pair coding partner, and and we've got to a point where it's possible to build quite complex applications without writing a single line of code, without ever touching the code, just by following this modern workflow, uh, where GitHub-based workflow, where we create issues, and then we assign those issues to an engineer, and when we assign those issues to an engineer, the engineer picks them up, maybe comments them, and then writes a spec for it. And then I review the spec. Like, this is how I work with engineers. I'll look at the spec, I'll comment it, we do back and forth. Once the spec becomes mutually acceptable, the engineer takes it, does the work, makes the commits, makes the PR. Another AI, or like in this human way, I review the PR gets merged, and we repeat this again and again and again and again. Now, in the AI world, we also have AI reviewing the PR. So then my role to view the PR is also becomes lesser. So that's a small change to the human way, is that now I also have a reviewer. So I have a different agent reviewing the PR. So basically, there is this very good way of working, the GitHub-based working that I had just described, and that's kind of what I'm trying to replace. So it's not that, it's just some agent that is writing code in Cursor. It's really this drop-in replacement for a software engineer. But, for today, we'll look at Cursor just a bit so that, whoever kind of like wants to go and then work with these things a bit, it's possible. But I thought that it's actually better for us because I'm happy to have more calls on this topic. We have a good group here, so it's great for us to talk about this topic in a bit more deliberate way. We're not here just to kind of do something for today or tomorrow, but really kind of work for the long term. So I think I'd start with explaining what I understand about this field, rather than like just jump into this high velocity way of working in the Cursor environment. So what we'll do today is we'll talk about kind of it's a bit like Drupta. So what is Drupta? What is Siddhanta? Drupta is really and I'm sure many of you are familiar, with that kind of category of Dharma texts, where mostly we are looking at how things are. Yeah. So rather than like thinking about practicality, like the whole point of Drupta is in a way to kind of almost ignore practicality and really just make sure that the words and their meanings are clear, and that these certain dichotomies with things are clear. So that's, I think, the approach that is really needed. Why? Because we are going into a different view of the world. We are moving away from a perspective that we cultivated for many decades, and we're moving into a new perspective that is completely novel to us. So just like a person who comes from not having any previous exposure to Dharma, it's extremely important for that person to study Drupta. Because if they don't study Drupta, the other things will not make sense. Because they're stuck in a worldly perspective. They're stuck with that perspective that they are highly adapted to. In Tibetan texts, we talk about, especially when we go to a bit higher texts like Anu Yoga, already in Mahayoga, but especially Anu Yoga, we talk about the channels, tha. We talk about the tha taking the shape of the syllable. So when we have the syllable for example. So we talk about the tha, the channels, taking the shape of the This is very profound, by the way, but it's also extremely practical. And that's exactly how we need to think about this. Right now, our channels in the West, we say, are neurophysiology. They're not parallel concepts. They're not like one-to-one parallel concepts. But I think when we say tha, lung, tigle, so the the channels, the winds, and the bindus, or you know, it's not yeah, it's not, not easy at all to translate tikle or bindu into English. So I'll just leave it to tikle slash bindu. So actually, in the West, we have this concept neurophysiology, and neurophysiology is not exactly the same as talung tikle, but it's similar. And it's very important for us to understand this here, that if we try to take our adaptation, our current adaptation, into this new way of working, it won't work. We will not get good results. We'll be frustrated, disappointed, all these different things. So we really need to first change our perspective, and then we need to cultivate that perspective. And we need to cultivate that perspective as far as we need to, in order to witness, to experience this neurophysiological adaptation to this new way of working. So really, it's those kind of steps that we need to take. So we really need to start by making this kind of perspective very clear. And we come up then with a few key concepts here. So let me just share my screen and draw out a bunch of stuff that kind of sets the stage for us. So let's start by talking about the way that I like to think about the different options we have. Like how can we embrace this new world gradually? Like rather than jumping straight into this like kind of end game, where it's almost that the agents are doing the work for us and we're more like supervisor. So let's talk about the different kind of approaches to working in this new way. So the way that I like to do it the way that I like to explain it is through pair programming, and pair programming really is a way of developing software where two engineers work together, where one is watching and one is working. And then the one who is watching is kind of giving input all the time and all that. So it becomes much more deliberate way of working than just one guy working by themselves. So let's say the first option is that pair coding partner who codes. So there's always the pair coding partner who codes, and then there is the pair coding partner who watch. So who observe. So let's make it like that. Pair coding partner who codes and who observes. Observes. So like that. So we get the idea from this actually, because really, then after this, what we get is, that's what I call agent dev0, and that's really the fully automated one. So I think really what we want to do here is that we want to move in terms of gradual progression. Okay, so we don't want to like straight away jump into that kind of fully automated workflow. And one reason is that it will not give us the neurophysiological adaptation. The channels won't take the shape of this new way of working if we just try to jump straight away to this completely new world without taking this gradual progression. And let's now talk about each of these a bit. And let's talk about the options that so this, I am the pair coding partner who codes. I am the pair coding partner who observes. And then I just kind of zoom out and let the agent dev0. And here eventually what we'll have we'll have eventually what we'll have is we'll have many of these. Yeah, so we'll have a bunch of agent dev zeros doing different works that they are highly specialized in, like that, kind of. So that's kind of like where we end, that we have an n number of agent dev zeros, and then we can kind of zoom out and just manage. Yeah, so we just manage the work. So then what we could say here is, this is, I'm doing the work, I'm observing the work, I'm observing the doing of work, I'm planning and managing work. And then here, I might not be even planning, because I might have one agent dev0 who is specialized in planning. So here, I'm managing work. And I think we can make it a bit cleaner here, like just focus on what is like the focus of that state. Here, the focus of the states is more like I'm planning work. And then here we shift into the end game, which is that I'm managing work. Okay? And in each of these, there is a common theme, and that common theme for all of them is I'm improving the agents, okay, and I'm improving the system of work, because that needs to change a bit, and then I'm developing or cultivating, like GOM. It is really like when we talk in Dharma, we use the term GOMPA. In English, we say cultivate, so that we understand this worldview, and then we gradually cultivate the adaptation to that style of work, so that we start to experience this. Then in Tibetan, we say nyam. This term nyam is that we are experiencing it, and that is what we in the West we call adaptation. We don't say nyam, we say adaptation. So we don't talk about gom and we don't talk about nyam. We just kind of bring those two terms together and talk about adaptation. So if you want to become a world-class chess player, well, what you'll do is you'll first figure out how to play chess. Then after that, you start to figure out this world view. What is all the words? What is all the meanings? What is all the hidden meanings? All that stuff. And the more we do that information part, the more we start to shift to that experience part. And then due to immersing ourselves with that experience part, then out of that comes what Tibetans call realization. And of course, we use these terms in the spiritual context, but those terms apply exactly the same to worldly affairs. It's not that the ancient Indians, just came up with a completely different way to deal with spiritual matters than the worldly matters. On the contrary, what they did is that they looked at the way we actually function. They looked at how we actually learn new things. They looked at how we actually experience, how those learnings become experiential, and then how that experience translates into toppa, realization can sometimes be a bit confusing, but it translates into that. It translates into actualization. So rather than it being a temporary experience where we dip in and out from that, it translates into an actualization. It translates into trade chains. So these are the language that is called used in cognitive sciences today. Is that we talk about state chains, which is nyam, experience, and then we talk about trade chains, which is doppa. So now I'm using these terms here talk about, in a way, somebody might say, hey, but we're talking about a worldly matter. But the whole point that I was just making is that we need to think like that. It's not that, it's two different things. It's the same thing. And obviously, we all understand that it's not so much like if it's software engineering. Software engineering can be dharma in exactly the same way as ringing the bell, or whatever, some ritual, some highly ritualized form of, like a puja, chöpa, then that's it. Is not the different thing, is like maybe different motivation. And that's where the difference comes in. So actually, it's very useful for us to talk about these things from the same perspective that we talk about spiritual practice, because that's what we would like this thing to become. We are working on these things that are very, very valuable, and if our motivation is right and our way of thinking is right, then there is no reason why our work couldn't become practice. So I think we need to be able to think about things in an integrated way and not make like these kind of fake, made up differences between those things. So just to talk a little bit about that to avoid any doubt that may arise there. So I am cultivating neurophysiological adaptation. This is very important, guys. So this is what we need to understand first, okay? And we'll come back to this in a bit. Now I'll move on to next thing that we need to cover. And let's just take from there one thing to start with. So there's kind of like a way to think about software engineering projects in a very highly structured way in terms of the different kind of phases of work. So basically what we have is in a typical setting, we'll have an idea like that, and then from the idea we have actually I have a better way to do this. 1 second. Yeah, 1 second. Okay, cool. So okay, so this is what I call a pyramid of goodness. And why it's good? It's good because it ties the mission of the project with individual commits. So first, every project has a mission. So there is a mission statement, and there is a shared idea. There is a shared belief on this shared mission, or there is a shared belief. First, there is a shared understanding, and then maybe based on that, there is a shared belief on our joint mission, what we are doing, what we want to achieve. And mission can be most readily understood by attention. It's a tension. It's not a negative tension like stress. That's not the point. But it is a tension. It is a kind of tension that comes from the fact that we think that the world should be something different than it is now. So we see that the world is something now. Like, for example, we see all of us know that there are about 200,000 texts in the Tibetan corpus, give or take, between 100,000 and 300,000, somewhere there. So there are unique texts in the order of hundreds of thousands in the Tibetan Buddha Dharma corpus. And we know that the world doesn't have access to those texts, or that access is constrained, that it's not really readily available. We know it from our own experience because it has prohibited ourselves for years and years and years and years that we don't actually have these texts kind of at our fingertips. So then that's kind of at least one way to think about the mission. Obviously, the Interjala mission is a bit broader than that, but that's more like the open Pecha side of things, the data side of things. So just to give an example. Then from there, we get strategy. And for the strategy, it's really just a plan. And a typical way to think about strategy is that mission, the time frame for mission is years. Okay? So let's do that. Let's put a bit of context here. So here, the time frame is years. It means that our mission is gonna be the same for many years. Okay? Then when we go to strategy, this we do annually. So this is annual. So we do a strategic plan typically. There's strategic planning window that almost all projects do strategic planning starting from around September. And then September, October, November, we all do the strategic planning. And then, in the December, we present there's many systems, but a very common system is OKR, which is coming from the words objectives and key results. So we decide what are our OKRs for that year. So we go to 2026. In 2025, we plan our 2026, and then we break that down into objectives and key results. So there's always that pair of an objective. This is what we want to do because this is the most important thing for us to focus on with regard to our mission this coming year. Yeah? And then we say, well, that's a very good objective, but what is the key result of it? And then those become the guiding light for us to do. And this is extremely important in non-AI assisted way of working, but it's still much more important in an AI based workflow because we increase our velocity by about 5 to 10x, especially when we go more to the agent dev side. We can increase our velocity even 20x. And if we can increase our velocity of 20x, the risk of going on tangents, the risk of deviating from our mission dramatically increases. So it becomes even more important to double down on strategy. Then from the strategy, we get quarterly, and this can be monthly, this can be half year, but for a project that is already reaching maturity, it's usually a quarter. Okay, and then we still further break it down to actually this is like kind of also annual. It's almost better to think about that like that, and then this becomes quarterly. So we have a bunch of stuff for Q1 in the product roadmap and blah 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 blah, and all of this is now informed by the OKRs or whatever system we use here in the strategic planning phase. And then we get to the engineering work part, and this is all done by humans. So now we start to kind of get to this, so humans are doing. We start to get to kind of like, well, okay, how do we think about our role in this new world as we go into this? So this is all done by human. And then we go into the engineering cycles. This is not really actually, it's just a kind of a way to say, well, we move into the actual engineering work. So then we have work orders, and a good work order, like an engineering specification, it's probably going to be 1 man month of work. So this is kind of monthly, monthly or weekly. So that's kind of the time frame we are having here, so that we make those specifications, and then an engineer works with those, and then they make daily or weekly. So this is weekly or daily. They make pull requests, and then this is daily. So we make daily commits, and sometimes even hourly commits. So Okay, good. So that's kind of a good picture, and this is now where we get human slash machine. So now it's like we can start to work together. Okay. So here we have now clearly kind of separated what is our focus and what is our shared focus with the AI partners. Yeah. So now let's just look at this a bit. First, the work orders, when humans work with them, they tend to be monthly or weekly. But you know, AI can do engineering specification in 5 minutes or few minutes. So that is a radical change. So we need to appreciate that it's a radical change. And we need to adapt to that. So now we start to get to the things that we need to adapt to. If we want the AIs to start to do engineering specification, we have to double down on this part. Yeah? So this one is where we ensure that we don't get tangled with the high velocity, the velocity increase that comes in here. Yeah? And if the term velocity is not clear, it just really means usually we pin the term velocity to pull requests. So how many pull requests are we able to make in a given week, and how many of those we merge, and how many of those ended up in our backlog. And obviously, we wouldn't want any stuff to fall in our backlog, and with humans, that always happens. But with AIs, that doesn't need to happen. So these are really, really, really big changes to the way that we think about productivity, velocity being one of the kind of, it's a very primitive metric, but it is a metric of productivity. So we need to think about these things from the perspective of productivity and where can we find most leverage. And we can see that we can find a lot of leverage by having the AIs do the specification and us reviewing the specification, because it means this one becomes hours and minutes. That's crazy. That's just completely insane that we can, in one shift, go from monthly or weekly iteration cycle into hours or minutes. Yeah? And then let's see if we can do that same thing in pull requests. Well, the AI assisted workflow also reduces this into hours or minutes. So that's nice. So we can do that. And then obviously this one here moved into minutes. Like that. So now, okay, wow, that's crazy. Because that means that our objective becomes to reduce this whole layer of work to take place in this cycle of hours and minutes rather than month to hourly. Wow, that's mind blowing. So then let's move on. And after this, we'll jump into Cursor and we'll do today a basic overview of how to do pair coding as a partner who codes, how to set up Cursor to support these two ways of working. Okay, and then next time we'll go into how to think about this. But I think it's important first to develop that adaptation around here. So we'll focus on that. We'll look at Cursor features that are important for that perspective. But then I think here, I sometimes heard somebody say it's like, don't take it personally. So I find this is a very good kind of way to think about it. Is that the AI agent won't do things like we want it to do it often. Yeah, it's limited by its training material, and its training material is mostly very poor quality code because if you go into GitHub and all the training materials that the LLMs have, it's mostly GitHub. And if you go and you roam around GitHub, you find that 99.99% of all code is quite bad. So the way that the LLM learns to write code is quite bad. Yeah? So we need to know that. And if we know that, when it does bad work, we never feel like, oh, why did it do this again, and da-da-da-da-da. But we can actually approach it more like, well, I'm here to develop adaptation towards this new way of working. So no matter how many times it gets it wrong, that just helps me to give it better information. That just helps me to kind of understand the agent. And that's what it's about. The agent will not learn to understand you. That will not work. It will not work because the training material it has supersedes whatever you're doing with it. So yeah, temporarily you can get it to kind of follow constraints and so on, and this is quite important, but it's never going to understand you. It's not going to understand you any more than a dog can understand you. So if you ever had a dog, if you think that the dog understands human language, then you will never have a good relationship with that dog. But if you more have this compassionate approach, where you understand that it's you who needs to understand the dog, empathy, you have that empathy, I think you're going to have a good relation with your dog. So it's the same with LLM. It's same with babies. It's same with a lot of stuff, different stuff. So we can just apply that idea of empathy here. So the other way to say this is empathy. We need to have empathy towards the agent. And this might sound crazy because it's not a being, it's not sentient. So why must we have empathy towards something that is not sentient? But actually, it's more like we are having empathy to ourselves. Because if we keep getting frustrated with the AI, or we are disappointed and we're stuck with all those emotions, it is ourselves who is going to suffer a great deal, and it becomes a big impediment to our ability to work in this new way. Okay? So let's jump into Cursor now. So let me open up a new Cursor here. Just 1 second, then I'll share my screen. Okay. So let me think what to do. Should we just start something new? Yeah, let's do like a project we can use as a one moment. Okay. Okay. Let me now share my screen with you guys. Okay, for some reason Cursor is not interesting. One moment. For some reason Google doesn't allow sharing it, so I need to figure out. Here. Oh, interesting. If it's in full screen, Google Chrome doesn't recognize it. So what we're going to do is we're gonna have a look through first, and first just a bit about Cursor. So maybe I'll just open the screen. 1 second, hold on, this is a bit strange. So new file, okay. Hello world.py. Let's just put that there. So now first, Cursor is an IDE, which is oh yeah, and interesting. So now that I'm sharing, I'm not able to make it full screen. So it's some limitation with Google Chrome. So first off, what we need to understand is that actually it's a pretty good working environment. And what I mean by that is that it's fully integrated working environment where we have our file system here on the left, we have our terminal here on the bottom, and we have our text editor here in the middle, and then we have the agent here on the right. And I'm using the pro version of Cursor, so I found that with AI tools, if you use the free versions, it tends to be garbage. But then when you pay, it tends to be pretty good. So for myself, all the tools I use, Claude, ChatGPT, Cursor, all these tools that I use, I have the license for them that is according to my needs. And here it means I think $20 a month. Now there's a caveat to that, is that when you use these premium models, so if you use the Sonnet 3.7 thingy, you can see there is an additional cost. But I found that to be quite reasonable. It's well worth it. So that's really a point I want to get across here. Don't be afraid that these things cost. They are not a cost alone, they're cost and value. So if I can save my time, 10% of my time, but if I have to just pay for 5% of my time, it means I have 100% return on investment. And that's very easy to achieve here. But more, I would say that I can get 10 times my time. 10 times. So then I can calculate what is the cost for my time, and then I see, okay, so I can get 10 times more things done. And then I multiply my cost by 10 times. And then when I see how much I pay to Cursor for the premium calls, and especially the MCP calls add to this, because all of them will cost based on this. So 5 cents per call. But then when I work on it, it ends up being a tiny fraction of the value I'm getting from it. So the takeaway here is do not be afraid to pay for the tools. Pay for them. Always subscribe for the paid version, and do not be afraid of extra charges. We're doing all of this here manually, so we do have a bit of oversight. So it can't be that it's just spends hundreds of dollars and you won't know that. And it will never do that anyways. They're not made like that. But it's not gonna happen. It's not like when you work with ChatGPT API, where it's you can end up spending quite a lot of money, and you don't know it. You just know it you've run your loop through whatever. So that will never happen here. So don't bring that mindset from working with the APIs, where we need to be very worried about the cost, in here where we don't actually want to be worried about the cost. We really want to have cost. Okay? So one way, working with APIs, very worried about incurring cost. Other way, here working in Cursor or similar, we want to have cost. Okay? So take that with you. Now, the way we're going to work here is to try not to go out from here other than going to GitHub to get an issue that we've written and pasting that issue here and then asking it to work on it. So that's all. Other than that, we don't want to go out from here. We want to really be here. We don't want to bounce around, going to another window, and that is very detrimental to both productivity, so how much work we can get done, but it's also very detrimental to the ergonomics, which is how we feel getting those things done. So one thing that for me changes with the AI way of working is that I no longer need to go do Google searches and all that stuff, and that's really big. All I need to do is work in GitHub and here. But today we won't do the GitHub part yet. Today we focus just on Cursor, so for the rest of the time we'll stay here. So let's now look at how to set up Cursor. So there's a few things we need to know that are going to make a very big change to how much you can get out of this. The first thing we need to know is that we need to know that it matters which model we're using. I'm almost always thinking using the thinking one, and this is the max one. But then it's a bit more cheaper, so it's less intelligent than max, but it's also much cheaper. And it might not incur any extra cost because all it does, it consumes your cursor requests. Whereas this will add more money. So you can always work with this, and if it doesn't do the job, then you move here. And by the way, when you have one agent, then you don't want to do all the things in there. But what you want to do is you want to have ChatGPT or Claude on the side so that you can ask any lengthy discussions, all that stuff you can do outside of this chat, because Claude has a pretty short limit for how long one chat can be. So we want to extend one agent, so one chat here, as long as possible, because then it has all the knowledge about that task. But we don't want to use the same chat to work on two different tasks, but instead, so let's get started here so we can make it a bit more concrete. So make a hello world function in hello world .py. So let me just add one more thing here. Now, before we do that, this is how we start. Is that we have this empty chat here, and then we add context to it. Okay, and we have a bunch of context here we can add, but I guess in this case we just want to add hello world.py. Yeah, so there's no code there now, but we'll start with that. So make a hello world function in hello world.py, and that's it. So that guy starts now its work, and blah 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 blah. It's doing a bunch of stuff, and then that's it. It should be able to finish this work quite quickly. Okay, good. So the work is done now. Okay, and now let's say that we wanted to move on to another task. Then usually it's better to let's say we've now worked here for a while. Then it's better to start a new chat, so that you are actually working with a clean agent, so that agent doesn't have any confusion coming from everything that you've been doing with the other agent. So think about the agents like task specific. So I'm going to work on this one part of the application. So I'm going to work with one agent here on the right, and I'm going to have one chat in a separate window just using the desktop client for Claude or ChatGPT. And then whenever I need to discuss things and so on, clarify things, blah, 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 I try to do it there when I don't think it's strictly needed to do it here, so that I can keep that one, now this hello world chat, that I can keep it going and going and going and going, maybe even for a whole week. I can keep it going. That's very valuable if I know that I'm going to be working on a certain part of the application for a while, but that I need to kind of bounce around different parts of the app. So I'll end up having different chats for different parts. Okay? So that's what we need to know about the chat part. But just doing that part will not get you far. That's very basic. So where the power comes, really the real power, especially as we start to move from, us writing code and it reviewing it. So sorry, I didn't do that. So actually what I should have done is just write this code myself and then use this agent and ask it to review it. So let's pretend now, before we move on, let's pretend that I wrote this code. Okay? So this didn't come from the AI, it came from me. Okay? And then the way I use the AI in the first phase, where I write code, I am the programmer in that pair of programmers, and the agent's job is to observe. Then I just ask, can you check my code and let me know if I can improve it yet? And now comes very important. No code, just discuss. Myself, I mostly don't use the agent to write code unless I'm really committed that that whole project is just for the agent to write code. Or if I need to do like bigger sweeping changes, I need to do a lot of repetitive blocks of code, blah, 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 then I ask it to write it. But I often just use it as a way to check what I'm doing. And then this no code, just discuss is very important. And in any ways, even though if you wanted to write code, still do start by saying always no code, just discuss. And then you kind of plan together. And then once you feel comfortable, then you say, okay, implement it. And what you can do also, what I really like, and that's where LLMs are really good, is give me options. And the way I like to work with options is that I say, give me a simple option, a moderately complex option, and a complex option. And then I kind of use that as a way to guide myself. Where do I want to go? Is it something that I just want to get quickly now done and minimize complexity? Or do I want to actually go a bit deeper? Do I even want to build and forget? So I just build it once and never think about it again. So that's a really good way, is to, so first off, no code, just discuss. Then second, give me simple option, moderate option, moderately complex option, and complex option. Okay? So then it gives me those, and then we might discuss more, and so forth. And another constraint that is really common for me to use, and these constraints are extremely important. Otherwise it gets tangled, it's gonna do these big sweeping changes and so on. So another thing that I like to do, and these are really the important things, so let me add them to the keynote, so we'll also have these things here. So constraints, you won't see my screen, so I just say it. One, no code, just discuss. Then one is give me options, and then one is only change the file, that one file, only change that one file. So when I want to change it, I say only change that one file. I found that to be one of the most important things to understand. Only change that one file. Because otherwise they tend to go into this rampage of big sweeping changes. And then a very important one, no fallbacks. They love to do fallbacks which hide native Python errors. And we don't want that. We want the code to be really naked. No fallbacks. Because otherwise, how can we know if the code actually works and all that? And LLM, more than any other thing, loves fallbacks. Because beginner engineers, and most of the code is done by like quite low-level engineers that they use for training material in GitHub, all the stuff from all the students, and it's mostly that. There's very little elite engineering code in GitHub when we put like all of GitHub, and elite engineers don't do fallbacks. Never, never, ever. You just build bulletproof code. The LLM doesn't have that idea because it doesn't have that in the training material. So this constraint is extremely important. No fallbacks. Okay? And we'll now go into how to like make those static, like how to make those constant, so that you don't need to say them every time again and again. But okay, it said, so potential improvements, 1, 2, 3, 4, 5. Then what I do, I review. Add project infrastructure. Well, we already have that, so that's a bad feedback. Create basic README, we have that. Start changelog, we have that. Add simple unit tests to demonstrate. So 4 and 5. Consider packaging structure for future expansion. So, okay, implement 4 and 5. So this will be kind of a very natural way of working. So no matter how complex the thing you're working with, this perfectly illustrates my approach how to go through those steps. It just means that when you're working with something more complex, it might be that you're doing this back and forth chatting without approving any implementation targets yet. You might go with this for 30 minutes or 1 hour, and that's extremely valuable. Okay? Extremely valuable. It helps you a great deal, and it helps the AI a great deal. And this is one of the things that we can't have with humans. With humans, we have to sometimes wait for days or weeks before we can have the discussion. And then once the discussion time is over, we might again have to wait, hours or days or weeks to continue to the second part of that discussion. These are impediments to our work that we don't want that. What we want is we want to have this kind of constant flow of progress. And here we see now the first really game-changing feature of the AI, because it allows us to go into that deep planning mode and not come out of that before we know exactly what the interventions are that we want to implement. Okay, so now while it finishes the work, we'll go to the conclusion of today's session, which is setting up Cursor so that this works in an ideal way. So how do we do that? So we have one thing here that we need to worry about, and that's cursor settings. And in cursor settings, first off, we have the general cursor settings. And in the general cursor settings, we just need to, we don't need to do anything. Good. So features is where we need to really make sure that stuff is good. So here what we want to focus on is we want to make the default chat mode into agent. Okay. We want to have, I'm not really sure what that even does. Yeah, this is more like UX. Auto apply to files outside, yes. Include project structure. So yeah, this we definitely want. That's a new feature. So we want to have that on. Enable auto run mode. This is the most important thing. Without this, you don't get the power we're seeing here. So enable auto run mode. Then command allow list. We don't want to have any of these, because then these will all restrict the power that it has. And then we can do stuff like don't edit end files, outside workspace protection. So I think it's a pretty good practice to have that, because again, these agents do like to go sideways and do big sweeping changes that you didn't ask. That's one of their favorite things. Fallbacks is one of their favorite things, and big sweeping changes is one of their favorite things. And always suggesting code changes immediately when you ask them is another thing they love. And that's why those 3 constraints are so important. So large context, we need to put it on and iterate on lints so that it will iterate as long as the lints are okay, the lints are passing, allow the creation of custom modes. Not sure what that is. But we don't need to look those things now too much. Then here, code-based indexing, we need to have all this. And 1 second. Sometimes if we didn't work on that project for a while, we might want to come and resync. And I don't think we need to look more of that. Then models. In the models, you choose the models that you have as options here in this menu. And I don't even never use Gemini, so I should just remove it. So let's remove Gemini and let's remove all those things. Oh, ChatGPT 4.1, it's there. Cool. Okay, great. So now I have everything that I want there, and you might want different models, so you'll just put those models there. But this is something that we need to do. And as you can see, I don't have any of my keys here, so you don't need to do that. My extra billing goes all through Cursor, and that's fine with me. So I don't need to add anything here. Maybe you can add if you want to add, but now we get to the main point, and these are very old rules. I haven't updated in a long time, so I should update them, and I'll do that for our next session so that we can have this like kind of gold standard rule set based on my current understanding of these things. But this is where you come and do things like constraints. So you add the constraints here. And when I created these rules, it struggled a bit to understand what's the good way of using these MCPs and so forth. And always update changelog. Not good. This is really bad because for some reason they struggle with changelog or the dates. They make like they hallucinate on the dates. And then the other thing is that then you yourself have to also update the changelog. Otherwise, what happens is you end up with inconsistent information. So if you do have a changelog, you have to make sure that it's absolutely complete, because otherwise every time they get the context, they look at the changelog and then they see, okay, so these are the changes. But if you don't have all the changes there, now you're giving incomplete information to the LLM. And for the LLM, it's better to give complete information or no information at all. So, but we'll go more to this next time, and I'll put this together nicely, and we'll go to that. So this is for every project you have. So no matter which code base you're working on, you'll always have these certain user rules. But then you have project rules, and project rules are similar rules, but they're project specific. So a lot of the good stuff that you will do with regard to giving the agent a better way to work is going to come from the project rules. And now all of this, like here, I say always start by using sequential thinking MCP. That leads us to the MCPs. And there's a couple of MCPs that a lot of people are using, like sequential thinking. I'd say that that's the first one you want to have. If you're worried about code coverage, then you should add code coverage here. And for a human, if you say to a human, give me tests that give 100% coverage, that can be extremely painful job for the human. But for the LLM, it's pretty straightforward, and it can kind of automatically keep iterating, keep checking with code call, and once it has 100%, it's done. Okay? But when you do code call, like give me 100% code coverage, again, you need to really constrain it to just changing the test file, because otherwise it will start to iterate between changing your code and changing the test file to make your code more testable. And that's for sure not something that you want. Yeah? So those constraints are extremely important in everything that we do here. If you work more on building UI components, 21st Dev Magic is probably among the best there. Also, if you work on front end, you definitely want to have browser tools so it can see your console and it can take screenshots, and so it just has much more better code awareness. And then the GitHub is not really needed because it has access to your GitHub through Cursor, as long as your Cursor is connected with GitHub. So it'll know how to just use bash commands, shell commands to do all the GitHub workflow stuff. So if we did have an underlying repo, we could say now, okay, commit this work and make a new PR, and then we have either Copilot or CodeRabbit or both doing a review there, and that all happens automatically. And then 5 minutes later, we go there and we check, what was the code change. Is always important to check, make sure that you know exactly what changed. And then if you feel okay with everything and AIs didn't have any big gripes, any big problems, then you just accept it. And then you take the other issue and you put it here, and you kind of keep doing that. But we won't go to that now. That's a much more advanced way of working. We'll get there eventually, but that's kind of how you can think about it. So I think now let's close it for today. If there is some like questions, we can still spend a bit of time here. But for me, what I wanted to share, I have shared it now. So for whoever is interested in this now, the homework here is to go and set up this working environment at the MCP tools, at the rules, so that it knows to always use sequential thinking, for example. If you have some specific things you want to implement, just add them to the rules and see what happens. And then kind of start to work in this way, but don't start by it writing the code. Just start by you writing the code and having it review it, and then use it for planning together before you write the code. You can ask it to give you code examples and so on, but you write the code. So do that for a while, and then gradually move into where you're no longer writing the code. You're just communicating and it's writing the code. And you can even write the ticket and just copy paste the link of the ticket here and then say, no code, let's discuss. And then you make the spec better here together. Then in the end, you ask it to summarize all that in a new version of that ticket. And then it can go and actually edit that ticket as well, but you might just do it that as well manually and just take that and go and update the ticket and then say, okay, let's go work with this now. That's the second phase. Okay, but do not start with that. Start with the first phase.
Okay. Thank you, Mikko. Guys, I think we'll have a question answer session for like 15 minutes, and then I guess we can call it for a day.
Yeah.
If you guys have any questions.
So today you have gave us demo about how to use the cursor, right? But currently in our organization, everyone is using Windsurf. So for the homework that you gave us, regarding uh, putting all the rules and going through the settings, we can do the same thing on the Windsurf setting, right? So
Yeah.
Okay.
Yeah, they are both just VS Code. So actually, Cursor is just a brand, white labeled VS Code, and Windsurf is also. They just take a little bit of different, like their Drupal is a bit different, but everything that we talk today is like applicable to both.
Okay.
It's not different, yeah.
Thank you.
And Mikko, can I know why did you choose cursor
Over others.
over other similar thing?
So yeah, I think that right now, if I chose a tool, I'd probably look at Claude Code first. I tried it a bit. It's in command line. It's a bit different feeling, everything. So I tried that, and I know a bunch of people are trying out Windsurf. And really for now, it's really just kind of, okay, we have these few options, maybe Cursor, Claude Code, Windsurf, and then there's a bunch of plugins to VS Code. And now, their Copilot is becoming better, much better, so then you can do VS Code with Copilot. So I just want to make that clear because I'm not in the view that Cursor is better than any of those other solutions. I'm maybe in the view that I myself might want to do more of Claude Code in the future, give it a chance. I took Cursor initially because one my colleague, very experienced software engineer, then he said to me that among the things that he had tried, Cursor was the one that he ended up using. So I ended up using Cursor, and but I didn't end up just because of that. Then I reviewed these tools, and that time Windsurf was still kind of up and coming. So they still had limitations that were not acceptable to me. And Cursor didn't have those limitations. So, but since then I saw they also became better. And yeah, now VS Code and Copilot became better as well. And because I really love GitHub way of work, I'd probably go today to VS Code with Copilot.
Mm-hmm.
Yeah, like if I had to choose again. But then at the same time, my personal curiosity is more towards Claude Code. So I think that it's really not that important which tool we use. It's just important that we use one tool so that we become experts in it, that we develop that neurophysiological adaptation, right? So I think, it doesn't matter. Like, as long as we have one of these like leading tools, and then we just learn that really really well and share with each other the way of working and problems we have and so forth. So
Okay.
So one other question I have is, so you mentioned about two very important things to keep in mind while asking for the agent to make changes. One of them is to specifically asking to change only one file. So for that you gave us example and you wrote change only one that file and giving path to or name of the file. So that is clear. But about the fallback one, so about the fallback, so do I need to include the fallback condition inside the rules, or do I have to write it every time when I ask it to?
yeah, I will put it to the rules. I will put into the rules no fallbacks, naked code,
Okay.
or no fallbacks, just native Python error messages.
Okay.
So I would put those kinds of things into the user rules. And again, the user rules that you're seeing in the screen, they are not good rules. So those were like some months ago, and that time Cursor had a lot of problems that it doesn't have anymore, or the underlying LLMs had a lot of problems they don't have anymore. So a lot of those rules now are completely unnecessary. And now I think the rules need to be much more just about the constraints, so that it doesn't go sideways, but it just really focuses on the task at hand. And I think that that's one way that we need to think about things, is that in the past we often thought about changes in terms of like a bunch of files. So it's like I have these 5 files, so I need to change these 5 files at the same time. And for a human, that's kind of painful, but for LLM, this is not suitable way of working. So this is part of the adaptation, is that we learned create more like single file structures. Yeah, so it's like one file is really containing everything for that thing. That like we think, okay, whenever I'm developing this thing, well, it's calling all these other things as well, but those I don't need to change. So let me make sure that all the things that I need to actually keep changing and that I keep developing, all of that stuff is in one file.
Okay.
Any other questions?
Yep. Hi, Mikko. My name is Keche. Thank you for the great session. My question is about vibe coding. Like the one vibe coding that Andres Capaldi mentions was like something that you don't really know under the hood and you just know what it does, kind of thing. And like the one that you define is more like an engineer, like you really know like everything, what's going on, and you just create like one chat for a function and everything, right? So the thing is that I actually tried Cloud Code and Windsurf and like Cursors, and I did create some applications. But the thing is that we are so used to being an engineer, right? So we usually know everything about our apps, like how this function works, because you like manually write everything, right? So now with the shift, you like I sometimes I create an app, but I really like don't know what's happening under the hood. Do you think like with vibe coding, this will become uh, like we have to get comfortable with like not knowing like everything about a system, or do you think like still we have to deep dive of like whatever the AI has like coded, we have to go deep down and really understand everything in the system?
Yeah. So right now, right now we're in a well, I think that first, just zoom out a bit. So when we talk about software systems, we tend to have this idea of how there's a term business critical. And that just means that if that software makes a mistake, how bad it is. And if the answer is that it's not bad at all, that it doesn't matter, or if the answer is that it matters, but it's very simple to see it, it's like the user will know. So then in that case, I guess that we can even go more to the direction where it's like really all just AI, and the code is made so that it works for the AI, so that it's easy for the AI to develop it and so on, which is quite different from human. So, for example, they love fallbacks because the fallbacks then have some messages, and then they read those messages so they can see what's happening. So we don't want that, but they want that. And that can be one way to think about it, is like, well, why? So they have a very different preference than what we have. We want the code to fail in a kind of a naked way, and they want it to never fail in a naked way. They want to have a lot of elaborate messages coming out for every fallback. So then that's a good kind of example of that. Well, probably a code that is entirely done by AI, which human doesn't really understand even, in the kind of extreme case, well, then that's probably easier for the AI to maintain, probably. Yeah, so it gives more power there. But I think that if the application is business critical at all, where errors do matter, we absolutely 100% must understand the code base entirely. Yeah. So I think that that's kind of the way to think about it. But yeah, there is cases where it's not critical, or it's a bit critical, but the user will immediately know when there is something wrong, and that's not a big deal. If that's not a big deal, then yeah, why we don't need to understand the code. I mean, I understand that a software engineer would like to say that, of course, we always have to understand the code, but I'm not sure that we do, because why would we if mistakes don't matter? The only reason why we do really have to know the code is two reasons. One, if mistakes matter, we need to know that before we merge the code, that it won't have mistakes. Or then the other, if we ourselves want to keep on developing it. But if we ourselves don't want to keep on developing it, but we just really want the AIs to keep developing it, then yeah, why? There's no reason for us to understand the code or look at the code or anything, actually. Yeah, but it's going to be a big pile of cheese. They are not good programmers. They don't understand architecture. The agent is a bad programmer. Okay, so it's exactly like working with a bad programmer, but they're very good with planning. It's like working with an experienced planner, but they're not good with thinking intricate logic. They're not good with thinking about redundancy and all these things by themselves. And you can only give those inputs to them by actually looking at the code. So you can look at the code and say like, wow, you made a bunch of spaghetti here. Let's clean this up. And then that alone might be already enough for it to look at it and say, yeah, okay, I see. It is a bunch of spaghetti. Let me make it cleaner, and then make it cleaner. So then we can kind of see is that, well, if we don't look at the code at all, it's not just about if the code have error and so on. It's also that it can really become like a big pile of cheese. And the more of a pile of cheese it becomes, the harder it becomes to manage for the other agents later. Yeah? So I would say that for everything Indrajala is working on, we have to understand the code completely.
Okay.
Thank you.
Any other questions? Okay, I think I have one last question. Then I guess we can call it for a day. Because lately I have been, you know, working with Windsurf as well as similar infrastructure like Lovable in order to make simple website. But as Geshe has mentioned, I have a small um, uncomfortable feeling that okay, even if I'm able to, even if I manage to pull off the application or like the website, so how will it be when it comes to maintenance of that particular website? You know.
Right, exactly. So that's the point about pile of cheese, right?
Mm-hmm.
Like I myself have been in situations where I'm pulled into a project, into a new project, and everything is just absolute nightmare. Everything is huge mess. All the codes are just like copy paste templates, and then try to fix them, and that's horrible.
Yeah.
Like that ruins the project
Mm-hmm.
basically. So you are right. This uneasy feeling is not. We shouldn't ignore it. Like we should not go to that pile of cheese direction, and that's why these constraints, like first really planning together, no code, just discuss, use time with that, just change one file, having double AI code review and ourselves reviewing the code, all this stuff. That's how we bring that comfort into it. So every step of the way, we're just building that conviction. Because in the field of engineering, we have this term conviction, which is the same term in Dharma as well. Is like really what we're doing is we're building conviction. We're building bulletproof conviction with what we're doing. Is it the Dharma practice or is it the code base? Is not different in this way. It's really we're building conviction. So let's not lose our sight of that. Let's not become mesmerized by these tools and opportunities. Let's really figure out gradually what all of this means, and let's adapt this new way of working and this new worldview. But let's not compromise, things that make engineering great. On the contrary, let's double down on them because now we have less time going into all the mundane things. So we can put more time into doubling down on core engineering principles.
Okay, I think with this, I would like to thank Miko for conducting the session. I guess we will definitely have another part two or some sort of like that for this session in order to have more discussion on um, the agent develop dev0, because like I think vibe coding, the title of meeting seems a little bit undermine the what you have um, mentioned today. And yeah, as I think it was a good reminder for me and Tasring also, because we have seen the pyramid of goodness before, and it was a also nice that we all of our team got introduced to the pyramid of goodness.
Yeah.
And yeah, it this is one of the things that can't change, that I have witnessed.
Yeah.
And I think it would be I think definitely many of our developer might have learned through this one in order to not only develop a code or a package that they are assigned, rather than that, you know opening their mind for a bigger picture and how it is supposed to be and all those things. Thank you for that. And then gradually we came across how to set up the cursor. I think it will be similar, as you have mentioned, it will be similar for the windsurf also. Definitely we will do our homework regarding how to you know um, set up similar thing that you have done on the cursor to the windsurf. And also I would also like to request my team, if you guys want to experiment cursor, definitely we can you can opt for that one, and then reach out to me when it comes to the payment, because anyway we have to pay, we are paying for windsurf. It's like we can have both options. Yeah. So I think that's it. Thank you, Miko, for the session.
Thank
Yeah,
you.
Thank you. We will have another session in a month, and in that session, we can go to the OpenLink package and we can develop it a bit. So we can go into that like actual production phase.
Sure,
and
sure.
we can kind of go into that agent dev0 phase. And look at things through kind of a higher practical lens. Today we kind of set the stage more theoretical and just building the foundation, and then next time let's do it in a month, and then we can do work.
Sure. Yeah, and
Great.
lastly, I would like to mention one thing for all of our team, because like I believe many of us might be going to that direction where we are cooking up spaghetti in our packages. So with this session, I guess you might have got some understanding from, obviously, because Mikko is a very experienced developer. So I think any one of you will definitely reconsider when you directly press that apply all button in the windsurf or that thing. Yeah, that's it. Thank you.
Right. Thanks so much. 谢谢用，祝谢谢。
下马这样子些。
谢谢。